Okay, we are going to start the earth materials section. So this is one of your main compulsory courses under the first year syllabus, 1000 level syllabus. So my name is Sanjeeva Malaviarachi. I'll be conducting this earth materials part for you. So this part mainly consists of 4 sections actually. 4 sections means the crystals. First, we will talk about the crystals, right? That means the crystallography, because earth material means the materials which made up the earth, right? Yeah, because the earth is made up of many things, right? Natural things. So primarily rocks and minerals are very important. So we consider them as the materials, right? The materials that make the earth, not only the earth, all the planetary bodies, or we call terrestrial planets, right? So crystals, under crystals, we will be studying on crystallography, and minerals, that is we call the mineralogy, and regarding rocks, we study under the subject called petrology, and there is another one, that is fossils. Fossils means the records of biological imprints preserved in rocks. It can be plant fossils or animal fossils, right? Flora and fauna, which existed long time ago. Their imprints can be found in rocks preserved as like a seed, right? So that is called paleontology. The field which we study under that subject is called paleontology. So people who have already watched the Jurassic Park must be knowing very much about fossils, right? And also in biology, maybe in zoology, you will be studying some plant and animal fossils also. But here we will be doing some geological studies on fossils. So scientific studies on crystals is called crystallography, and scientific study of minerals is called mineralogy, and scientific studies on rocks is called petrology, right? So this is how we divide this section into groups, subsections, and we will be having some practicals also once the universities are open for practical work. So evaluation of this course will be based on assignments, quizzes that will be considered as continuous assessments, and then you will have a mid-semester examination and end-semester examination. So those are the evaluation procedures. For assignments and mid-semester examinations, up to 40% of your marks will be allocated, and the rest of the 60% will be on end semester examination, which includes theory and practical both, right? So again, for theory 60%, and for practicals 40% in general, right? Slightly these criteria can be changed for practical and theory mark allocation, but basically for continuous assessments is 40%, and end semester assignment assessments it's 60%, right? Studying on rocks, that means petrology part, will be shared with Dr. P.L. Dharmapriya, Prasanna Dharmapriya, and paleontology will be done by Dr. Nadisha Korlegathar, right? So today I will be starting crystallography and mineralogy sections. First, we will look into the crystallography sections. So this is a 3-credit component, right? Remember the course, earth materials. Okay, the objectives of this course is important to know. right? So here we will be mainly discussing on the structure of crystalline materials, right? So you should be knowing crystalline materials uh, that are actually the blocks of building blocks of minerals, right? Crystals which make the minerals. We study them, their properties and their structures under this crystallography section. And also it's important for us to understand the main concepts, right, preliminaries of crystallography, such as lattice, unit cell, symmetry, and some atomic position. So these are the main terms that we are dealing under this course. So you can consider them as the keywords because these are very important. Uh, because all the crystals they have different relationships in terms of these terminologies. So lattice, unit cell, symmetry, and atomic positions are very important. In addition, we will see some other aspects as well, but basically we will be looking at these parameters which in relation to the crystals. And symmetry is very important because it describes about the shape of the crystal, and you can understand uh, I mean how symmetric a material is, how symmetric an object is, right? That's a general understanding. So you have common understanding about the symmetry, the term, right? So similarly, the same applies to the crystals also. But the thing is, in crystals, we have different views of looking at. The ways of looking at crystals, crystal shapes, where we talk about the symmetries, crystal symmetries. Okay. Right. So this subject, actually, this is not an easy subject. This is a one of the most difficult subjects in geology, as well as in other subjects like chemistry and physics. Because in chemistry and physics also, crystallography is a major part of their courses. So, but I think in chemistry, you will be learning on crystallography at your third years or fourth years, right? Physics also same, but you will see different applications even in engineering. There are a lot of applications on crystal materials, right? Not only physics but also engineering, where the material science is taught, right? And in chemistry, definitely this is a major component. And mathematics also, some people study about crystals and their symmetries, because there are a lot of mathematical operations also related to crystals. And biology also, some studies on crystals are there. So please make a note in addition to geology what we are talking about. So now I'm showing you one crystal example. So can you just note what are the important features you can observe from these crystal shapes, right? This is snow crystals. So you just observe. I will give you a few minutes just to observe and let me know what are your observations are. Okay, have you observed the features? What are the features? Uh, the main important feature here, you can see, we have already discussed the important factors related with crystals. So you must be knowing. I mean, you can easily recognize them. Here you have some snow crystals, right? This one is a snow crystal, and this also a snow crystal, right? And this one is a diamond. Okay, this is a diamond. So what do you basically see in common, sharing in common? Can anybody tell me? It's, I mean, you don't need to be scientific, just an observation about the shape. Okay, let me show you. You look at this direction. Okay, anyway, first of all, they have a specific shape, right? Very systematic shape. That is the first thing you should notice, that, right? Very beautiful and specific shape, and very systematic. So that is one of the features. And the other one is, you can look along these directions where I am now making red arrows, right? So what do you think along these directions? What can you say? What can you observe? What can you observe along this? Hmm? This is very symmetrical along these directions. Can you understand? This is very symmetrical, right? Along that direction. Not only that direction, actually you have more directions as well, right? For its symmetricity. So these are very important directions. Uh, Please give me a minute. Yes, you observe the symmetricity, right? Along this crystal also you can see the symmetricity very clearly, right? So this is a important feature for a crystal, because we are talking about crystals. So one of the important features is the symmetricity is found in crystals, right? It might be in one or two directions, but in some cases, like this crystal, for example, you can find 6 directions of symmetricity. Okay, so this symmetric feature we call 6-4 symmetry here, because along 6 directions you can make this crystal into very exactly equivalent two halves. Okay, right. For this one, for what do you call this diamond also, you have two directions, and like this, actually not two direction, 4 directions. There are uh, uh, several directions that you can find the symmetricity. Okay, right. So you just observe the features here, right? Actually, there is some trouble with the power connection in my area, so they are going to switch off the power. So you might lose the power. So in that case, I'm not sure whether I can join again. But in 10 minutes time, uh, I will try to join. So please wait for 10 minutes. Sorry about the interruption. They are going to switch it off now. Right? The electric board has come here. They are going to do a repair, but it might take 10 minutes. Like, right? Okay, I will join back. If my connection is lost, please rejoin at 10:40. Okay, at 10:40. Until that time, until this connection is I mean, you are going to lose the connection soon, but you can write down this information which is appearing in the slide. Okay.